7 o'clock. Thank you to all who are still with us. I also want to give out a quick shout out to my mom and my aunt who are in the audience. It is my absolute pleasure to have three experts with me tonight about video games and intelligence. We have a nice slide deck for you, and I'm going to introduce the speakers in full as we get to their slides. But I want to welcome here Chabane, Ted, and Itzo. And in a second, when they start their slides, we're going to talk about what each of them are doing. So thank you so much for joining this panel. I've been excited all year for this opportunity. Let me share my screen. And thank you also, Yash Kumar, for doing tech support for us. All right. So it is winter right now. And as it so happens, winter is a very, it's a very nostalgic time. And recently it started snowing in Bloomington frequently. And it recently prompted me after 24 years for the first time again to play through the game Halo. It came out in 2014. I was 14 years old. I was a freshman in high school at the time. And I hadn't played it since. But recently I decided to jump back into it because there were all of these riveting winter scenes that I assume many here might be familiar with. And one of the really cool things about Halo that has really stood the test of time is its ability to have enemy AI. So on the left side here, this is a review from 2003 from the first Halo port to the PC that lauds its enemy AI. And having played through it again just a couple of weeks ago, really re-emphasized again just how amazing this AI still holds up to this day. And to those of you who might not be familiar with Halo, it is a first-person shooter. You go against the bad guys. It's all in a futuristic scenario. It's also very beautifully made. And one of the really cool things about Halo are the different enemy types. You can see these are all aliens. You have the grunts, which are basically just cannon fodder. They hang around in big groups, and they are usually guided by elites, which are those tall guys here in the middle. And then you got various other enemy types, but there's a really cool dynamic where grunts always look up to the elites. And if you are, somewhere in their game and the elites disappear, then the grunts will run away. And for the time, that was completely revolutionary. And even now, it still kind of blew me away just how immersive all of that made it feel. So there are just all of these amazing scenes throughout the game where grunts will see something that scares them, and if there's no elite nearby, they're just going to run away. So I don't know how well this just comes through here, but this grunt sees our spaceship and immediately runs away, and it kind of sets the mood for the entire game, because that's what they do. That's how the AI is programmed. Now contrast that with this game from 2023 that some of you may or may not have played. This is called Redfall, and it got really bombasted for its bad enemy AI. So this game is 20 years older than Halo. By all accounts, it should have much more advanced AI that is more believable. It gives a better challenge to the player, but it was not the case at all. It was one of the major reasons why this game flopped. And then finally, this is another interesting piece about AI from 2014, so kind of in the middle between Halo and Redfall. Shadow of Mordor had a system called a nemesis system, where if you frequently failed against specific enemies in your scenes, that enemy started getting a name and it became your nemesis. And then it kind of became your challenge to overcome this particular AI character. So this was one way of imbuing otherwise nameless, non-playable characters or NPCs with a kind of intelligence where it seemed like they would remember you and they would call you out as you encountered them again. So it is one way to make this whole thing feel more alive. And so to finish me setting the stage here, this is a very, very recent development from last year. NVIDIA showcasing some new AI NPCs, which gives NPCs the ability to react to unique player actions in real time, in some cases even with language. So the ability to be able to speak to an NPC and that NPC would respond to you in one very particular way that it wouldn't respond to anybody else, and that is not pre-programmed or canned. That is kind of the new frontier here. I don't know if that's a good thing. I don't know if that will always be used as a good thing, but that is one of the things that we're going to be discussing tonight that I think is a really exciting development in general. With that, I want to give it over to Ted. So Ted, Dr. Ted Castronova, is a professor of media at IU Bloomington. He invented the field of virtual economics in 2001 and has authored numerous books and papers on the subject. His consulting practice advises developers on the design of virtual economies and provides expert witness testimony on economic matters in the video game industry, representing both developers and players. And with that, Ted, I would like to give it over to you. Thank you so much for joining us tonight.
Oh, thank you for the introduction. There's a little donkey named Dewey. He's a cute little donkey, and he lives forever. He was born at the beginning of time, and he's lived on our Earth ever since, and he will go on living forever. You can think of him as sort of an angel in donkey form. And I'm writing a novel about the sorts of things that Dewey the donkey sees. Next slide. What kind of a world does Dewey see in 500 years? I think we've all seen this kind of a picture. Okay? The number of smartphone users worldwide going from 1 billion to 6 billion. It's almost universal, I suppose, at this point. Everyone has a smartphone. People who have smartphones may also have consoles, iPads, they may have PCs, game computers. They have screens upon screens upon screens, so many screens everywhere. And back in 2007, I wrote a book called Exodus to the Virtual World, where I said, now, everything happening in these video games is going to be so compelling that, people are going to leave this place. They're going to leave the real world and go hang out in virtual worlds. I was wrong. I thought people were going to go living in video game worlds, and that hasn't happened so much. Instead, with the advent of the smartphone, the virtual environment of social media is the place where everyone seems to go. Some people, many people still go to games, but others are just living in the world of Instagram or TikTok, their friends lists, and so on. That sort of version of virtual reality. I consider it all more or less a seamless virtuality. I don't think anything on this is actually real. So as we get more and more smartphone users, this idea that people are spending more and more of their time immersed in the world of the screens seems to be going up. And next slide. Here's a picture that most people have seen as well. So we don't know if it's causal that the growth of technology has caused fertility to decline. But I wrote a paper in 2009 predicting exactly that. And it's not a profound thought, right? The idea that people who spend time in virtual worlds would stop having children. Certainly for males, there's every kind of reasonable theory you could lay out as to why males would find themselves more or less satisfied in terms of their childbearing interests by the things available in virtual worlds. But I thought the real roadblock, the real stopping point would be women and their desire to have children being on or off. And I just sort of speculated. It was a speculative paper about, would it be possible for fertility to collapse while technology sustains the virtual reality that is causing fertility to collapse, right? And the key variable there is how quickly does the VR become automated, that is, does not require human input. And I think now we're at a point, we're at an inflection point for that as Andreas just showed us, game companies are moving over into the idea that the characters are AI. And there's great concern among game students, for example, that their jobs, they just won't be able to get a job because AI can do the art and AI can write quest lines and AI can code and so on and so forth. And so maybe we're at an inflection point where it all just sort of becomes automated. And if it is, my theory through all these years and everything I've been writing is that the screens will become this irresistible lure that people will increasingly simply be unable to avoid them, that they simply won't say no, that the experiences inside virtual reality will get richer and richer and richer year by year. Um, the stories, especially, I think that the literary pull. I think this is basically a literary situation. It's a question of compelling narrative, and it's just going to get stronger and stronger and stronger. I don't see anything in technology to make it go back the other way. And so I think these lines are just going to continue to go down. They'll just continue to go down. So the novel I'm writing, what Dewey is seeing, he's seeing a world 500 years from now. All right. So next screen, please. Next slide. This, I think, is basically what it's going to look like. Um, Folks watching at home may want to zoom in. The novel occurs in a world where there's a thing called the hive, and the hive is dominated by AI agents and some human agents that spend all day sending trillions and trillions and trillions of messages back and forth to one another to no real end. Right? It's just this endless, intense conversation that sucks up incredible amounts of power. But because there is a marginal cost to power, there's some limit on how big this machine can be. But that there are some people who choose not to live that way. And that's what's in the foreground here. Basically, what looks like a late Iron Age settlement, wooden buildings, basic technologies like wood, windmills, and blacksmithies, and things like this. And that these are the people who are actually uh, the human genome at this time. Okay, because if everyone goes into virtual reality and they die off, they don't breed, that means the genome in 500 years is going to be, it's going to come from people like the Amish, right? The ones who reject it all. And so the novel talks about what kind of a life do those people lead? What's their relationship to the hive? And my central thought is that the hive will go about its business. It'll suck up power. It'll suck up all the electricity. It'll go out into space. And for the most part, it'll ignore the human beings who just will have nothing to do with electricity. It will, for the most part, ignore them, except when, for some reason in the hive, it becomes motivating to go out and find those poor humans who aren't living in civilization and go help them. And to help them, they basically destroy their villages and drag them into the hive itself. And that's the central tension is of a little village that's trying to avoid that kind of oversight. So next slide, if I have another one, I'm not sure. So what I propose, what I think is going to happen, is I mentioned the Amish. Who is it? Who are the people who would not spend all their life in these? What kind of people? Well, it's not going to be utilitarian people because on a utilitarian calculus, it meets a benefit cost test very well to just sit in a chair and be perfectly happy with the electronic things that are hitting your brain. That passes all the cost benefit tests. And especially when it comes to having children, it's much, in terms of costs and benefits, utilitarian calculus, it's much better to have a virtual baby. You can just turn them off. If they cry, you can just turn off the cry button. Whereas real babies, you can't do that. So who would be the people who would reject that utilitarian calculus and commit themselves to having babies the old-fashioned way? And I believe anyone who's doing that would have to be consecrated to some higher calling. So I mentioned the Amish before. Why do the Amish live without electricity? Why do they keep having babies the old-fashioned way? Well, they do it because of a religious commitment. And I think traditional Catholics I spend a lot of time with, I think they would as well. But I think Orthodox Jews would and conservative Muslims. And I think people who are sort of religiously committed to nature would do so as well. And so I define a world, or I talk about a world in which those are the remaining people. This image here is a character that I call Saint Graça. This is Portuguese for grace, Saint Graça. And I call her um, Maleum Machinorum, the hammer of machines, because and she's not actually in the novel. She's a saint from a couple of hundred years before, but it was her. It was her. She defined how a community can live without the hive. And you see, she's here. It's a natural situation. There's the storms of electricity above her. This is an AI generated image, obviously, and she's protecting the children. So next slide, please. And so the story is viewed mostly from Dewey's point of view, as he has seen everything. He was alive right now. He was alive 2,000 years ago. He was alive 10,000 years ago, and he's going to be alive 500 years from now. And my novel, which is titled Dewey, talks about this kind of future. Thank you.
Thank you very much, Ted. Like a speculative fiction book, that was not something I expected. So this is a really great surprise. I say let's keep questions for the end when we have the panel discussion. Thank you so much, Ted. All right, next up is Izo. It's my pleasure to introduce our second panelist of the night, which is Izo Bukvic. Izo is a post-disciplinary creative. I like that moniker. Exploring and building technologies for a better tomorrow. His current research trajectories consist of low latency, synchronous musical co-creation over distance, oral immersion and broadening of human cognitive bandwidth in automotive scenarios, large-scale digital signal processing, including spatialization and data sonification, really covering all of the senses, and enhancing K-12 education through integrated technology-mediated experiential learning. Presently, Izo he's a professor in media arts and production, and also the inaugural director of the Kinetic Immersion and Extended Reality, or KICS Lab, of which my team and I recently got a tour. Thanks again, by the way, that was really amazing. And with that, I do want to give it over to you. Yash, have you had a chance to download the slides?
Yes, I have them downloaded. I'll be sharing them in a moment.
Wonderful. Thank you.
Well, thank you for the introduction. Maybe for the sake of time, I'll just say a few words before the slides come on.
Yep.
First of all, it is a great pleasure to be here. Thank you, Andreas, for inviting me. Thank you for Yash making the tech work. And of course, shout out to Ted, my colleague, my newfound colleague. So my approach to visioning intelligences is maybe a little bit different, in some ways bridges the previous topics we've listened to over the last 30 or so minutes. And it really talks about immersion through audio and the intelligences that not only encompasses, but also strengthens. And so let's start with something that they refer to as immersion parity. So when we talk about the world of immersion, there's a lot of time spent on talking about the visualization. As a matter of fact, even the name of this event, talking about visioning, sort of has roots in vision. And so what is particularly interesting about that is that oftentimes when I do these kinds of presentations and have opportunity to interact with the audiences, I ask him, how many of you know anything about data visualization? And usually 99% plus people raise their hands and say, yes, of course, we know what data visualization is. But when I ask him what is data sonification, more often than not, we actually get 0 hands up, which just tells you the big disparity between our ability to process visual information and do so consciously, and that same level of proficiency on the oral level. And so what you're seeing in front of yourselves is actually a dashboard of a card, which actually represents this problem in a very obvious way. If you were to enter in a car, imagine that you're in there with friends, you start a car, you get going, and suddenly there is a generic ding that comes from your dashboard and redirects your attention away from the road so you can look at this fancy screen in front of your on your dashboard. only to notice that actually one of your doors is ajar. And so then you act accordingly and fix the problem. What's curious about this is that we legally are not allowed to, for instance, play Netflix videos on our screens, which are increasingly bigger and more powerful in cars. And the reason for that is obvious, because it's a huge distraction and can lead to accidents and all kinds of other problems. And yet here we are, we're given a generic ding that actually begs for our attention away from the road so we can actually look at a screen to understand what is actually going on. It's kind of ironic, isn't it? Especially when you consider that new cars have over a dozen loudspeakers where we could easily project a sound from the doors that might be ajar. And even more so, we could project a sound that can actually inform us of what kind of warning it is. Because right now, in some cars, the same ding stands for anything from replenish your windshield wiper fluid to your car is about to blow up. Can I have the next slide, please? So there's a video here. So I'm going to play just a little video, 1.5-minute video that will hopefully amuse you, maybe even a little bit bore you, but will also give you a kind of a perspective of what this gap looks like and how it can be actually best leveraged. Maybe to also link up this with the conversation that follows. Really, the entire story of this is the story of immersion through audio and the ways how we can leverage that to a great extent, including this more sort of broader topic of intelligence. Assume that there's music. Music doesn't mean anything. It's really just there for your own enjoyment. So right now, I'll let you just watch this video. It's about 1.5 minutes. And to give it its punchline value, I will not say much other than maybe serving as a background music so you don't get bored by the silence of itself of the video. There are a few obvious things here to notice. Obviously, I'm driving a simulator on a computer. I'm not driving particularly fast. And of course, this is a simulated racetrack, which means I have plenty of margin for error, especially at these speeds. So if you're getting bored watching this, it is intentional. And just bear with me for another 30 to 40 seconds, maybe less. So as the camera moves, I would like to invite you to pay close attention. So if you're looking at the screen, try to look right. That red circle is a dead giveaway. In this simulation, I'm actually driving blindfolded. The entire point of this demonstration has been that I wanted to show just how much we're leaving on the table when it comes to oral immersion. So what I'm really doing is I'm getting the telemetry from a simulation, granted. I'm listening to it, I'm driving based on what I'm hearing. I have no visual perception whatsoever. Now, this is not to say we should have blind and visually impaired people driving. It is more to say, look how much more we can impart on a driver in terms of information. And this was a video I used, and if I can get a next slide, please, to spawn a partnership with a Bugatti Rimac company who are really interested in this work and trying to see how they can enhance in-cabin oral immersion, both to inform the driver, but also improve their driving performance. If I can go to the next slide, please. This is another example, roughly about 20 years ago, just about the time when, just after the Halo came out. I'm also a big fan of Halo, by the way, Andreas. I built this loudspeaker array where each speaker can be treated as a sort of a metapixel, if you like. There was a kind of a fishnet in front of it, one which you could projection screen, which was hiding speakers from vibrating and their vibrations, that they were not visually perceivable. and users could use Wiimotes to draw on this mesh. And what we projected on it was a sonification or representation of geometric shapes using sound. And so at the bottom, you see this A, B, C, and D kind of compositing process. So A is basically surface area of a triangle in this case. The blue is a little vector that moves around the edges of the triangle. And then as that vector moves around the triangle and hits the vertices, it actually highlights that C layer. And when those three are composited together, you get the visual representation of what it looks like in the D image. And the powerful idea behind this has been is how can we empower visually impaired to actually observe images? And so you can see in top right corner an image of a person participating in study. They are not visually impaired, but they were nonetheless perceiving a body of water with mountains and the sunlight right above it. And this tells you basically, again, same point. We have so much more to impart on the users through sound. If you could please do the next slide. I know we're coming up against the time limit here, so I'll quickly just breeze through a few more things. If you can click on that image also, the construction site, please. Thank you. At Virginia Tech, where I used to be before joining Indiana University, I took a part in co-designing and developing this space called the Cube. This is a photo of it. And you can see close to, well, you don't see all of them, but about 128 loudspeakers. And later, we also implemented multiple projection surfaces, cycloramas, a wearable VR that was also combined with motion tracking, etc. This was in 2013, as close as we could get to a holodeck at Virginia Tech. And to this day, this space continues to produce some of the cutting edge research across a broad areas and domains. And of course, audio is an important consideration in that research, but not exclusively. Of course, some research deals only with visual, some deals with oral, etc. As part of development of this infrastructure, I had to develop new software infrastructure that could actually drive such a system, because in 2013, there was not an off-the-shelf system that could just simply drive 128 loudspeakers to create complex images. So if I could have a next slide, please. So for this purpose, I developed a D4 library, and you can just slide through these next couple of slides quickly. So you can go next slide, please. You can actually stop here just for a second. You can see that in addition to the spatialization across multiple loudspeakers, this is actually the first system that also allows you to use the spatial mask, which allows you to essentially utilize the same methodologies that Photoshop enables when you edit the image, and even draw and listen to smileys, as is the case in this particular image. Of course, we can't hear anything right now, but we can certainly talk about what it sounds like and what are the shortcomings and advantages. Next slide, please. And the same thing also expands to the binauralization, which basically touches upon the video gaming side of things, and reimagining how we virtually hear when you actually participate in video games. And, you know, for the sake of time, I'll leave this as the sort of the last slide, or maybe can we just go one more slide forward? If it's the Kicks Lab, we might just land on that one. You can skip that one, please. Yeah, we'll stay there. So the whole idea is that when it comes to gaming, even though audio has advanced in great length to what it used to be, it's still lagging behind heavily from the visual side of things. Therefore, limiting the cognitive power and potential of these virtual spaces and immersions that we're seeking to bestow on our users. And so the binaural mesh that I've developed actually goes one step further to enable that next level of fidelity. But for the sake of time, I will not spend much time on talking about that, other than just to mention that since joining Indiana University, my goal has been to build what I aspirationally called the Cube 2.0. And this is actually a rendition I used for my job interview, which just imagines what that space might look like. And of course, this is just courtesy of Google Gemini. But needless to say, Kicks Lab is currently in the finishing. Well, it's in the process of being built out over the next course of the next year. The lab will be finished with cutting edge wall, crystal wall, multi-channel system, audio system, and motion capture as a foundation for building a community and research enterprise at IU that incorporates these modalities with parity in mind, and as a result also with new potential that can be realized when we broaden the cognitive bandwidth through multiple concurrent modalities. So with that, I'll stop there. Thank you.
Thank you so very much, Itzo, for taking us through this kind of, oral side, like the sonic side of intelligence. We're going to get back to this during the Q&A. I want to introduce our last speaker, and Chabane, great to see you. I believe you're 2 hours behind us right now.
No, just 1 hour. Just 1 hour.
1 hour. Okay, Central Time. All right. Well, it's great of you to join us. And maybe while Yash bring up the slides, I'm going to briefly introduce you. So Chabane Maidi is a creative technologist, educator, and entrepreneur driven by a passion for the intersection of creative media and systems thinking. Chabane is the founder of WizShot, which is a media company established in 2024 dedicated to researching and implementing novel creative media technologies. Chabane was previously at IU, lecturing at the Ladi School of Informatics, Computing, and Engineering with the Information and Library Sciences, and also the Media School, where he established the Game Lab, and where he helped start the new game design degree back in 2015. Chabane, it's great to reconnect with you. I want to give it over to you for your slides.
All right, I'm trying to look like my photo in the image. I guess I'll just say next slide when I'm asking for the next slide. I'll try to be quick. And so thank you, Andy, and thank you for the other panelists here. I actually played Halo 2. I played it competitively, went to a number of different tournaments, and I actually speed ran that level, Attack on the Control Room, that you showed. So this was it was a lot of fun. Anyways, so I have a lot actually to talk about, including in terms of envisioning intelligences, but I was kind of hoping to just leave that for the questions part. And I wanted to selfishly talk about what's more interesting to me or more directly related to the things that I do, drawing from an educator, online teaching teenagers and in the creation space. So I want to cover kind of a roadmap of intelligence technology and how it's impacting creators, education in this space, and subsequently the effect that it's going to have on the industry and gaming in general. Okay, so I don't have enough time for depth, so let's go ahead and go to the next page, and we're going to hopefully get through this overview of where we're at. So this is going to be a primer in terms of the terms and also status of AI technology. I'm just kind of splitting this into different sections. So go ahead, next page. So classically, when we use the word AI in game development for the last several decades, we're not talking about LLMs, generative models, or deep machine learning or any of that. We're talking about discrete traceable structures such as finite state machines, behavior trees, environmental pathfinding algorithms, and the such. A YouTube video I made on Totemic talks specifically about those different kinds of discrete structures that we deal with in game programming and game design. So you can go ahead and check that out, I guess, but for the sake of time, let's just go on to the next page. All right, so where are we at right now in terms of, I guess, generative models? So right now, the little animation that you see right here was taken from a video that was created on YouTube a couple weeks ago. And it showcases someone who used Claude, like Anthropic's Claude 4.5 model, and they just used a couple of sentences in order to be able to generate this prototype of this game, including all the graphics, all the sound. Actually, I'm not sure about the sound, but all the code and all this kind of design. They basically said, like, create a Vampire Survivors clone, but in space. So on a technical level, and I've been teaching university students and teenagers for a very long time, for a couple decades. These I would say that the technical level, like it's maybe upper class game design team could produce something like this in maybe several weeks, including all the graphics, including all of the design and implementation of the code. So that's where we're at right now, and you don't have to have any technical capability in order to be able to produce something like this. All right, so next slide. In order to understand kind of where things are going, I think we have to understand a couple of human tendencies, because there's a couple key biases within our own human intelligence that affect how things are going. So let's go ahead and go to the next slide. The first thing that I want to talk about is how hopelessly social people are. People like people, even with single player games. People say, I don't like multiplayer games, but single player games are really just multiplayer games, just collectively across the world. People all play the game together. They feel like they're joining a club of people who are playing the game. Even if it's the best single player game of all time, if they're not allowed to ever talk about it, they probably wouldn't want to do it. In most cases. So humans are hopelessly social. If you consider, let's say that there's a chess tournament and it's Halloween and it's also a costume contest or something like that, and you go there and there's no people there, but rather there's a bunch of like computer stations set up with like digital personas with costumes, and they're all set to varying levels of skill based on what you would expect at a local chess tournament. If you went to that and you were the only human there, you probably would be disappointed because you made your costume, expended all this effort and time building it so you could show it off to other people, not to bots, right? And you put all that practice into playing chess, into competing against people, not bots that happen to be exactly the same skill level as people. Okay, so that's something that we have to consider in terms of what we need. And go ahead into the next slide, if you would, please. Thank you. And the next human kind of tendency or bias that we have is what I call Lego mentality. And or kind of like duct tape mentality. It's basically how humans are have an aversion to cognitive friction or effortful thinking, right? They would prefer to press the easy button that they are already familiar with, fast and familiar. Press the easy button as many times as necessary in order to be able to create a task, rather than to do the difficult thing, which expends a lot of mental energy in order to learn the optimal solution for a particular task, even when you know that it's the optimal solution, or it's probably going to save you time in the future. And you might have heard of that story, the tortoise and the hare. And you might think like, okay, well, if I were to build a shed out of Legos, right? Slow and steady wins the race. I'll just put like 100 Legos a day and I'll build a shed. But actually, no, the Legos is the hare. Because if you look at the graph on the right, the simplistic time progress graph, where Legos, you're gaining a lot of progress immediately because you know how to use Legos and you're able to do the base structure of the Legos. But as time goes on, it's a logarithmic progress curve, right? Because Legos can't solve all of your problems. Like what about, electrical and piping and other types of structural elements are actually more difficult to do with Legos than to just learn what you need to do in terms of woodworking and so on. So actually doing the Legos thing is kind of the inverse exponential where you'll never actually finish. Okay, so go ahead and go to the next slide. Let's talk about kind of the current and projected landscape for creators and creatives, and therefore subsequently what's going to happen for the industry as a whole. So go ahead and go to the next slide. So I want to talk first about the different groups of creatives and creators in the pre-generative AI age. So internet, social media, and there's a whole separate thing, before the internet age altogether, but let's just focus on pre-generative AI. And I think we're still largely in this particular phase because despite what I showed that Claude 4.5 is able to do, I think that is far off actually. Like game design is kind of one of those last frontiers. Like we are able to generate music pretty well, and also images with near, imperceivable differences from reality. Games, I think, are still a little bit further off. So I think we're still mostly in this particular phase. And these different groups I'm going to categorize in this way. So group one, I'm describing as the driven, determined, intelligent one, people who will become masters of a particular craft. Enough understanding that they even are able to build the tools, the techniques, and the methods in the particular craft. And they are relatively resistant to distraction in order to even be in this group. Group two, I would consider them to be what I would call the means to the ends group. They're only learning the tools just enough to be able to create the product that they're interested in making. So really, they're very production oriented. And they're just learning just enough so that they can produce the product. They're going to college. They're investing time on YouTube and forums and whatever they need to do in order to be able to learn those skills. But at the end of the day, they're just interested in the ends. And then group three, this is a group of unknown size because these are the creatives, but they are not creating. They're not actually producing anything. And what I mean by that is they themselves are creative individuals, and they always wanted to get into music composition or maybe photography, but they just chose a different path in life, or they just don't have enough time to be able to learn those particular skills, and they're just kind of stuck in this gigantic group. So go ahead and go into the next slide. as we transition to generative AI. And I'll start from the bottom. Notice how the size of these different chunks of this pyramid are restructuring. And I believe that even since before the internet age, this is being stratified in the way that the top is getting smaller and smaller and smaller. And so group 3, we now identify its size. It's gigantic, right? Because this group is now creating. The creatives are now creating who weren't creating before. And I'm going to rename this group as prompters. These are the prompters, the prompting group. They're the ones who are using the Lego mentality. Remember that, easy, low cognitive friction, easy button as many times as necessary to be able to get to perhaps 99% completion. But they're not going to necessarily get to full completion, but maybe 99% is good enough for many of them. Okay, so that's group 3. Now, group 2 are largely the same, but I'm going to kind of rename them to the finishers. Remember, means to the end, so I want to focus on just ends. They're the ones who can, they understand the tools under the hood, the auxiliary systems well enough to be able to take something from 99% to 100%. They're the ones who are able to take it past the finish line. And those people still exist. The people I talked about that spend years in a game design program, they're the ones who are able to take it to 100%. But here's the thing. In the future, I think that this chunk of people are going to shrink because it's going to require a lot more motivation. It's harder to justify putting in that amount of effort to be able to understand the systems well enough to be able to read, process, and be able to create a reliable functional product from something that is generated. Being able to take something from 99% to 100%, I think that they're going to get stuck in group 3. They're going to stay at the prompting stage because if they can just, take just write a few sentences, just take a couple of days to produce something 99% of the way there, that's pretty compelling, right? Maybe they would rather just pay a finisher to be able to take something to production level quality. And by the same virtue, I think that group 1 is going to get even smaller because there's even more layers to come across, and we have even more existential levels of distraction along the way, a la what Professor Castronova had described in his consecrated birth community situation. All right. Go ahead and go to the next slide. So I want to talk about impacts and strategies. And I want to summarize what the future strategy is going to be in terms of industry and in consequence, the gaming, just gaming as a whole. Okay, so let's consider variables. Next slide. Here are some I don't know, next slide, please. Here are some basic variables. I think we can agree that the supply of games is increasing rapidly. And as we can see in this kind of article that was released a couple of weeks ago, Suno, which is a generative music composition tool, has announced that they're creating an entire Spotify. So Spotify is this catalog of human-made music, just virtually all the songs that you could ever think of. And Suno is creating an entire Spotify catalog worth of music every 2 weeks, and probably that's just going to get even faster. So if we were to project into the future in terms of gaming, you would see that the supply of games is going to be tremendously large, and the supply of gamers is not increasing at nearly the same pace. Potentially, it's even going to shrink. And also, current user retention monetization models depend on gamers playing more, but in turn, they're playing actually fewer total games. They're playing fewer total games. And so, do we have maybe too many games? Okay, next slide. Okay. So how is this going to impact strategy, industry strategy? And so what I think, and I'm talking primarily about indie games, not the games that are spending hundreds of millions of dollars in budget, or a new category of game that I predict called like Insta games, like Instagram, where you're able to create a game just entirely contextual to like whatever news is out, just some kind of games that you're able to share. I'm not talking about those. I'm just talking about the traditional smaller kinds of games, the ones that you get to see coming out of the game design program at in other different departments in the university setting. What kind of games will people play in this world? And the answer to that question is the popular ones. Those are the games that we're going to play. And it's just, that seems kind of like self-defeating. Like, well, what? Of course. Yeah, the popular games. But here's the thing. This is an old problem. There always have been too many games. Even before video games, there were too many games. Like, and any person can make a game, right? Like, it's not very difficult to make a game, but who cares about your game? Why would you play your game or your friend's game or some other game like that? Any full-witted game designer can be asked to devise a better version or better rules or more interesting rules for existing sports. And I bet you that any of them would be able to do so, because a lot of the rules of these sports are relatively arbitrary and not interesting. And so why are people playing existing sports, right? It's because people play existing sports. Right. And it's the same thing that goes with just games in general. There are a variety of high quality games that never really get played, whereas these really, really big games get played, even though, and I'm not trying to sound like, what is it? Anyways, I'll skip that. People play games because other people play games. And this comes back to the chess tournament problem that I was describing. And so because it's so easy to get to 99%, and a game just has to be good enough, more so than ever before, because learning new game modes is cognitive friction. That's why a lot of the game genres are all the same. And I think that it's going to become even more so in that direction because people already have less tolerance for that type of cognitive friction, as shown by studies of critical thinking with AI, as some of you have seen in the kind of academic space, that the types of brain centers as scanned from imaging shows that we're using a lot less of our critical thinking as we can as we have in the past. So tolerance for critical thinking and cognitive friction is going to diminish. So as long as the game is good enough, we're okay. Right. So instead, you want to spend all of your resources, virtually all of your resources, into marketing, in a new type of marketing that I'm calling reality crafting. Okay. Our old tools of marketing and creating the perception of popularity are paying influencers money, right? It's to make people be like, oh, cool, the influencer is playing a game. Direct advertising to make it look like the game is maybe larger than it actually is. But we now have new tools for reality crafting and creating this the perception of popularity, such as bot astroturfing, right? In social media spaces, we're able to use these different language models to create different bot users that astroturf the popularity of a game. You're able to actually use LLMs in the games themselves, as Andy had mentioned before, that you're able to make characters, NPCs, that are indistinguishable from human characters. So, and also you can behaviorally train AI on player data, again, making NPCs appear more human than they actually are. And now you're able to get with this local chess tournament situation where you feel like you're entering this space with other human beings. So as long as you can craft that reality and create that illusion of popularity, then those are the kinds of games that are going to succeed. And that's the direction that I think that more of these resources are going to be poured into. Tools for finishing and training other people on how to effectively finish games, and also reality crafting in the form of marketing. Those are two general directions I think we can look at ahead. So that's what I have for this. And sorry, it wasn't as much about envisioning, the actual visualization of intelligence, but I have a whole lot more to say about that.
I bet. No, this was good and focused on AI, on so somebody who actually makes video games and teaches making video games. So I want to give a little thought exercise to the panel, to Itzo, Chabane, and Ted, if you guys want to turn your cameras on again. What was the last time you interacted with an AI in a game that legitimately surprised you? I can start. For me, as I was describing in the intro, I expected the gameplay in Halo to feel really stale after 24 years. I thought, I was 14 at the time. I probably just made this up to be something much bigger and better than it actually was. But now I was replaying it, and I was just blown away by how immersive it felt right out of the gate. So what was your last experience where AI just surprised you?
So are we including in AI the kind of structures that Chabane was talking about, like not LLMs, but just the general idea of programmed response?
Yes. Mm-hmm.
I think for me it would be EverQuest in 2001, where I came into the world and there were NPC ogres talking to one another, and I thought they were people.
They were
For
people
me,
because
I couldn't
because it
tell.
felt so natural.
I couldn't tell, whether the characters that were talking, whether they were human beings or NPCs, and then I discovered they were NPCs.
Chabane, how about you?
That's a good question. It came out of left field, and I wasn't expecting that one in terms of being surprised. Um, I couldn't say the last time that I was surprised by an AI model inside of a game, because generally speaking, if I can just speak candidly on the subject, generally speaking, players don't want to, and I can't speak on behalf of all players, right? When we talk about how like lifelike an AI is, part of it has to do with like how predictable it is, right? And generally speaking, the AI has to be predictable enough for the game to be fun, right? If the AI has too much agency, then what's stopping them from just like leaving the village and you never find them again and you can never complete your quest? You see what I'm saying? There's certain expectations of predictability for these AIs, and the same thing with like bosses and even the elites and the grunts. It can be impressive, right? But it still has to be within a framework of pattern recognition so that the player knows kind of what to expect. Otherwise, it becomes, I think it becomes, it leads to frustration, especially when it's like a friendly companion AI. You want them, I think generally people would prefer their AIs to be intelligent, but slaves. They're highly predictable, intelligent slaves.
Right, right. Yeah, that's a good observation as well. Itzo, how about you?
so two parts to this question. One, actually, I really appreciate Shabane's angle, and I want to add to that in a moment. But first, I'll say something about me being impressed about with AI within the context of Shabane's definition of AI, which is Half-Life. Both Half-Life 1 and 2 for me have been rather impressive in that you would for the first time see actually an enemy who is hiding behind the boxes, the ubiquitous boxes which are in every single game, and lobbing a grenade. Like you didn't expect that to happen, right? I think that was always that was quite impressive, both when 1 and 2 came out. But to add to Shabane's also point and also expand on that is, to me, it's like the challenge of making games is that we always want to have a hero's journey, which means that everything has to just be like hanging by a thread and somehow you thread a needle every time. And this fear and staying away from the mundane, because mundane infers the mundane nature of life. And if we had fully unrestrained AI where they left the village and never to be found again, in real life you would have other story, like story would completely pivot and you go do something else. Maybe you would just become a really good farmer as opposed to a person who saves the planet. And that's a journey worth telling too. And I think maybe at some point in the future, when we do reach the general AI capacity where things are procedurally created just for our sakes, we will be living in that second world where actually stories will be written the way they want to be written. And then AI doing whatever it wants to do will be actually a welcome addition. But as of right now, with games being a sort of escape from reality, we need to continue having these stories that thread the needle and make it worthwhile telling. So
I think that's a very optimistic outlook. I do want to end with one quick question, and that is,
Your minds, what kinds of traits and qualities does an intelligence need so that it can be perceived to have agency? Like a video game character, what traits does it need to show so that the player actually thinks that it's an intelligent one? So for example, Chabane, you mentioned that it can surprise you, but not surprise you too much. That's like a trait where even if something is not very sophisticatedly written or programmed, it can still feel alive, even though it's completely deterministic. So what kinds of features do you think, in general, does an agent need to be perceived as intelligent?
I haven't answered this, but I don't want to monopolize this if the other two want to speak.
No, go ahead. I'm not sure. I'm not sure humans have agency.
I think when we're talking about the illusion of agency here, we're basically creating personified elements. So even like a death animation for an NPC is entirely static, but if you have a variable death animations and it's contextual to how you killed them, that creates some agency. Like, whoa, no, you look like, any emotive expressions. I think just automatically creates this illusion of agency. Reactivity and, for example, aggro. For example, when you limit perception, like the cone of vision, blocking walls, players' presence through sound, right? It makes it seem like, oh, look, they're able to hear me, even like they can't see me or this kind of thing. That makes it seem like there's agency. But to what you were saying about grunts, I think grunts in Halo, self-preservation, where they choose cover instead of aggression when they're hurt, or when their boss character is like the elite is no longer there, their handler is no longer there, so they have to choose cover for self-preservation purposes. And you feel bad. You're like, I can't kill this grunt. He's like, no, help me. And so you don't want to kill it, even though it's just some basic behavior tree, that's telling it to do that. And so it makes you feel like it's choosing to survive, but it's all a discrete model. There's nothing particularly intelligent about it. So
I love all of these very concrete examples that you brought. And I also love that the conversation kept coming back to Halo. Obviously, we made a mistake in that game. Thank you so very much for jumping on this panel. There's never enough time to talk about video games. I really appreciate you coming out on this beautiful Saturday night. I'm going to give it back over to Todd, who's going to have the next hour. Thank you all, and have a good evening.
Yeah, thanks a lot, Andreas. Nice
Thanks,
to see you guys again. Bye.
Yeah, thank you, everyone. That was a great panel, great discussion.